All right, today we're going to talk about 10-5, which is a bunch of different angle relationships in circles. Really pay attention to how these angles are formed and understanding the vocab that is going on. The first one is a tangent and a chord that is creating the angle. So we clearly have a tangent line here and a chord. When you have a tangent and a chord, the vertex angle A is on the circle, and each angle that is formed is 1/2 of the measure of its corresponding arc. So notice how in angle 1, it's intercepting this arc over here, so it's going to be 1/2 of that arc. So down here in for number 1, in letter A, we have a chord and a tangent, and when it cuts through the circle, it is cutting through a circle that has an arc of 240 degrees. So in order to find the measure of angle 1, we're going to take 1/2 of that, which gives us the fact that angle 1 is going to equal 120 degrees. Letter B is going in the opposite direction. It is telling us the fact that this angle made up of a tangent and a chord is 155 degrees. So then that means that the arc that is intercepted by that angle has to be twice that because we're going the opposite direction. So that means that it is going to be equal to 310 degrees. Another type of couple types of angles that you can have are angles that are inside the circle, but they are not the center of the circle. So notice how there's not a center part that is marked here. So when we look at the measurements of, say, angle 1 here, when I finish drawing the chord and the chord, because of vertical angle, so it's angle 1 or opposite that, it touches the circle in 2 spots. And it touches the circle, intercepts the circle at arc DC and arc AB. And so in order to find the measure of angle 1, we're going to add up those 2 arcs and divide by 2. That's when the vertex of the angle is inside the circle. When the vertex of the angle is outside of the circle, and there are 3 examples down here where angles 1, 2, and 3 are all vertices that are outside the circle. And when I draw them with either a secant and a tangent, or a tangent and a tangent, or a secant and a secant, it intercepts the circle in 2 different arcs. In the middle one, it's the big arc and the leftover arc. On this far right one, it is the big arc and that small arc. And in order to do that, you are always going to take 1/2 of the difference of the arcs. So notice how in both cases it's big arc minus small arc divide by 2. So when the vertex is inside, we take 1/2 of the sum of the arcs. And when the vertex is outside, we're going to take 1/2 of the difference of the arcs. So, looking here for angle X. Arc X is this arc. So I'm going to be looking at this angle then, which means when I draw those chords, they intercept X and 80. 94 is really not going to be used for this one, other than the fact that this is a linear pair, so I know that the other angle here is going to be 86 degrees. And so when I'm looking at that 86 degrees, that vertex is inside the circle but not the center. So going back over to here, inside the circle, not the center, is 1/2 the sum of the arcs. So my angle of 86 degrees has to equal 1/2 of the one arc 80 and the other arc x. So I can get rid of the half right away, multiply both sides by 2. And then subtract the x, or the 80, and I'm going to get x is 92. For the second example, the vertex angle A is the angle that is created by a secant and a secant. And that angle is outside of the circle. So remembering, outside, the angle is equal to half the difference of the arcs. So 35 is going to be equal to half of the difference of the arcs. And where do the purple secants intercept the circle? At 100 and at x. So half of 100 minus x. Multiply by 2 to get rid of that right away. 70 equals 100 minus x. And I get x is 30. There's another way to look at the tangent angle. It's called a circumscribed angle, but when you have a tangent and a tangent here, the angle and that small arc, that minor arc, are always going to be supplementary. So it's another quick way to solve something like this. So looking then at number 3, first off, this is a central angle, and reviewing a central angle, that means that it is equal to the arc. So it's 124 degrees. And so then I know that the 124 and the x must be supplementary to each other, which allows me to get x is 56 degrees. Same concept here. We have a tangent, so 42, and then it goes to that arc. So first off, 42 degrees. Corresponding to that arc, I know that it's supplementary, so that arc is 138 degrees. So now this has a multi-layered problem here. Now I have to look at angle C, which has the x in it. And it is an inscribed angle with the vertex on the circle. So I'm going to take my 138 and divide it by 2 and get x is 69 degrees. So a couple practice problems dealing with what we're talking about. There are 3 different cases which we're going to review. This first one has its vertex on the circle. So with this angle being 48 degrees, it is equal to half of that arc. So I can say because the angle is 48 degrees right there, then this arc is 96 degrees. And then I know that the whole circle equals 360 degrees. So then the measure of x, y, z is going to be equal to 264 degrees. For number 2, angle x is a vertex that is inside the circle, and remembering that a vertex inside the circle is equal to half the sum of the arcs. Problem is, x does not correspond to the 2 arcs that I have. So I'm going to find y first. Y corresponds to those 2 intercepted arcs. So that means that y has got to be equal to half of the sum of the arcs. So y has got to be equal to 118 degrees, and then I know that x and y are supplementary to each other. So then x is going to equal 62 degrees. There are 3 different angles we're looking for in number 3. 3 different variables, x, y, and z. So we can start in a couple different places, but the circumscribed angle, the double tangents, is an easy one here, where I have 2 tangents right there. So I know that the angle and its corresponding arc have to be supplementary to each other, which means that that has to be 136 degrees. Angle X is now a inscribed angle that intercepts that arc. So angle X must be equal to half of that arc, 136, which is 68 degrees. Z is going to be done the same way, except I first need to find Y. So Y is dealing with the fact that all of the arcs in a circle have to add up to 360. I have 2 of them already, so I can take 360 and subtract my 60 and my 136 and get left with Y, which is 164 degrees. Then dealing with angle Z is made up of this tangent and this chord. So it's got to be equal to half of that arc of Y. So Z has got to be equal to 164 divided by 2, which is 82 degrees. These next few pages are review. So it's just kind of going over the different